All right, so we are revising Chemistry 1002 Quiz 1, which was for the July intake at Apex University. Okay, so the first question there is saying, provide the meaning of the term an electron orbital. Okay, so what does the term electron orbital mean? Okay, so an electron orbital, okay, is just a region within an atom, okay, where there is a high probability of you finding what? Electrons. Okay, so that's the common used definitions. Okay, so when it comes as a multiple choice, they'll try to twist here and there. Okay, so we just have to find that definition that aligns with what I just said. Okay, so an electron orbital is a region in an atom where you have a high probability of finding what? An electron. Okay, so when you look at these answers here, which one is close to what I've defined there? Okay, so when we say space where an electron is located, okay, so that is close. So we can keep that answer. And then here they're saying an electron pathway. No, okay, so an electron orbital is not a pathway. Okay, and then C, they're saying an energy level of electrons. No, okay, that is not correct. And then D, they're saying atomic space for bonding of electrons. No, okay, so the electron orbital is not used for bonding, okay? It's just a place where there's a higher chance of you finding an electron. So here the best answer you would pick was A, okay? An electron orbital is just a space where an electron is located, okay? So that was question number 1. So if you have any questions, be free to ask, guys, okay? All right, and then question number 2, what is it saying now? Okay, so question number 2, they're saying provide the meaning of the term a valence electron. Okay, provide the meaning of the term a valence electron. Okay, so if you remember these electron diagrams from grade 10, okay, you had the nucleus there with the protons and neutrons, and then you have these energy levels that were surrounding the what? This nucleus, okay? And in this energy levels, you found your electrons like that, okay? So a valence electron is that electron that is found in the outermost what? Shell, okay? So the outermost shell of an atom, if you find an electron in that outermost shell, that's what we call as the what? A valence electron, okay? So here we'll go for B, which is the best answer here. So the valence electron is just an electron in the outermost shell of what? An atom. All right. Okay. All right, and then question number 3, they're saying what is the golden rule in chemistry? Okay, what is the golden rule in chemistry? Okay, so the golden rule is, okay, let me give this example. Okay, so there is no person in this world, okay, that wants to not be at peace, okay, to have a peace of mind. Every one of us, okay, strives so that we can be peaceful with our friends, we can be peaceful with anyone. And in that way, we'll be able to enjoy our life, right? Okay. So the golden rule in chemistry, okay, the golden rule in chemistry is that, okay, whatever chemical compound you're forming, okay, whatever products that you want to produce, okay, your golden rule is to lower the molecular energy that is used in that process of you doing anything that you want to do. Okay, you want to lower the molecular energy, not formula, sorry. You want to lower the molecular what? Energy. So what is the importance of lowering the molecular energy? The importance is that you are going to attain stability for that molecule, for that compound. Okay, that compound is going to be stable if it has a what? A lower molecular what? Energy. Okay, so if I can picture it, if let's say I have this jar, okay, and in this jar, I have these particles. Okay, so these are particles here. So if these particles, okay, okay, they are at a very high energy, okay, they are at a very high energy, they're going to be moving, okay, they will be rapidly moving around in this jar, and this jar won't be stable, okay? Or let me not even give this example. For example, you are in a bus, right? If that bus is overspeeding, okay, then it means that that vehicle won't be stable, okay? You can easily be involved in a road accident. No wonder we've seen sometimes these vehicles, they fly, okay? Where do they get the ability to fly? Because they have such high energy, okay, that makes them so unstable. Okay, so they will leave the ground, then they will fly like that, okay? But if you have a lower energy, the speed of a car is just normal. It's very rare for you to what? To be involved in a road accident. Okay, why? Because you have a low energy. Okay, meaning your car will be what? Will be stable. So that's what the golden rule in chemistry states. It just states that any molecule that you have, okay, we strive to achieve what we call as the lower molecular energy. Okay, so if you have lower molecular energy, it means your compound will be stable. All right. Okay, and then we go to number 4. So if you have questions, please ask guys. So question number 4, they're saying, what is the meaning of the term atom in chemistry? Okay, so this is a grade 12. Is it grade 10? Okay, this is a grade 10 answer. Okay, an atom is just an indivisible particle, okay, of an element. Okay. All right, so an atom is an indivisible particle of an element. Okay. So you can't separate it into something else. Okay, it's just like that. Okay, so it's an indivisible particle of an element. So here we would go with A here as our correct answer. Okay, and then question 5, they're saying how many ways are commonly used in chemistry to describe the electron distribution in an atom. Okay, so how many ways? Okay, so let me ask you guys. So how many ways do you think are common for describing the electron distribution? Hello? Okay, so how many ways are commonly used in chemistry to describe uh, the electron distribution? Okay, so one of them is what we call as the electron configurations. Okay, those things that we are writing in the first shell, I have 2 electrons. In the second, I have 8, blah, 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 like this. Okay, and then this one here can also be represented when you have those specific orbitals. You say in 1s, you have 2 electrons. Okay, you go to the 2s, you also have 2, and then you go to the 2p, maybe you have 6. Okay, so this here is a representation of this electron distribution. Okay, even this one here is a representation of the what? Electron distribution. Okay, so from this, you can come up with what we call as orbital diagrams. Okay, orbital diagrams from that electronic configuration that is in this form. Okay, so we mainly have 2. Okay, so the first one is this one, the traditional electron configurations. And then the other one is where you use orbital diagrams, okay? Or you use the specific orbitals in which these electrons are found, okay? Right, so you mainly have 2 ways. So you pick 2 ways there. Okay. Are there any questions there? All right, so let's look at question 6 then. Question 6 is saying, what are the 3 brides of an atom? Okay, so they're just asking you what 3 subparticles are contained in the atom. Okay, so we know we have a proton, a neutron, and what? Electron. So A there is our best answer. Okay, and then question number 7, what is it saying? They're saying in an atom, which electron has more energy? Okay, is it an S electron, a P electron? Both S and P electrons have the same energy. They cannot be compared with one another because they are two different electrons. Okay, so an electron in a higher shell will always have what? A higher energy. Okay, so if this is my first shell, and then I have another shell, and then I have another shell like that, that electron which is here, it means it will have more energy than the electron that is there. Okay, electron that is there will have more energy than this. Okay, so now when we come to the orbitals, we know that the lowest energy orbital is the what? The S. And then you go to the P, and then D, and then what? F. So the electrons that are found in this orbital S are the ones with what? The lowest energy. Okay, so here we are comparing the S orbital to the P. So which one has higher energy between this S and the P? Okay, it's definitely the what? The P. The electron that is in the P orbital will have much more energy than this guy here. Okay, so the best answer there would pick B. Okay, all right, and then we go to question number 8. So question number 8, they're saying what now? Okay, they're saying provide the meaning of the term electronegativity of an atom or a group of atoms in a molecule. Okay, so what is electronegativity? Okay, so electronegativity, okay, it's just the ability of an atom or a group of atoms to attract electrons to themselves. Okay, that is what we call as electronegativity. Okay, so when you go to the periodic table, we say fluorine has the highest electronegativity. Why? Because it has a higher affinity to attract. Okay, yeah. So the between atoms in a molecule, you can refer to them as electronegativity. Okay, so electronegativity measures the ability to attract electrons in a what? In a bond. Okay, all right, so the best answer here is this guy here on C. Okay, electronegativity, it means electron attraction between atoms in a molecule. Okay, so that attraction there is what we call as the electronegativity. Okay. All right, and then question number 9, they're saying define the term ionization energy. Okay, so what is the ionization energy? Okay. Okay, so when if you have an atom, okay, and then that atom gains or it loses an electron, okay, the energy that is given out, okay, or absorbed when an electron is released from an atom or it is gained is what we call as the ionization energy. Okay, so the best answer here would pick is this B here. So ionization energy is just the amount of energy given out when an electron is released, okay, or the amount of energy absorbed when an electron is what? Is gained. Okay, so that's what we call as the ionization energy. Okay, right. And then question number 10, they're saying, okay, question number 10, they're saying quantum numbers are used to describe or locate electrons in atoms. Okay, which of the following statement is incorrect to describe an electron in an atom? Okay, so we are looking for the incorrect statement. So meaning the other 4 are what? Are correct. Okay, the other 4 are correct. Okay, so the first one, they are saying the principal quantum number. Okay, so the principal quantum number is represented by n. So the principal quantum number simply means the energy shell number. Okay, so if this is the first energy shell, its principal quantum number will be 1. The second energy shell, its principal quantum number will be 2, just like that. Okay, so it's represented by n, and you can see it will take the numbers 1, 2, 3, 4, just like that. Okay, so this statement here is correct. Okay, and then the magnetic quantum number, I've skipped this one because that's the correct answer. Okay, it's the correct answer here because it's incorrect. Remember, we are looking for an incorrect statement. So this statement is incorrect, but I'll come and explain it later. Okay, so when you look at the magnetic number, okay, so the magnetic number is just from the minus of the angular momentum quantum number, okay, to the positive of the angular momentum quantum number, including 0 itself. Okay, and then the spin quantum number, you just have 2 spin quantum number. It's either it's positive half or it's minus half. So it's positive half if an electron faces on above like that, and then it's minus half if an electron faces down like that. Okay, so this statement is correct, even this one is correct. Now, when we come back to this angular momentum quantum number, okay, the angular momentum quantum number is defined by L is equals to 1, 2, 3, all the way to what? N minus 1, and not n plus 1. So this n plus 1 is the thing that is making this statement here to be incorrect. So by definition, you have to know the definition of the angular momentum quantum number. It's just from 1, 2, 3, all the way to n minus 1. Okay, so if you're talking about, let's say we're talking about the second shell, our n will be 2, right? So it means your angular quantum number, okay, will just be 1 to what? N minus 1. So it means for the second energy shell, we only have 1 angular momentum quantum number. If the shell was 3, then it means that this angular momentum quantum number will be L is equals to, we have 1, 2. That's all. Okay, so here by definition, you have to have n minus 1 and not n plus 1. So this n plus 1 makes this statement incorrect. Okay, and then it will be our answer here because we are looking for the statement that is what? Incorrect there. Okay, so if we have any questions there. Right, no question, I'll move. So we now have this table here, which we shall use to answer question 1 to 15. Okay, so they're saying use the information given in the table below to answer questions from 11 to 15. Okay, and then they're saying neon has an electron structure of 2,8. Okay, so meaning in the first shell, we have 2 electrons. In the second one, we have what? 8 electrons. Okay, so let's look at what we've been given in this table. So we have this element W with atomic number 11, mass number 23, and then electronic structure 231. Okay, and then we also have this X, we have Y, and then we have Z. Okay, so now let's look at the question. So the first question here, question 11, they're saying, which element has 12 neutrons? Okay, is it W, is it X, is it Y, is it what? Z. Okay, so which one has 12 neutrons? Okay, so remember, how do we find the number of neutrons? We just subtract the mass number. Okay, so remember the mass number is equals to the neutrons plus the what? The protons. This proton is the same as atomic number. Okay, so here we've been given this mass number. Okay, so if you do mass number minus the atomic number, you get the number of neutrons. So if we make n the subject there, to be mass number minus the proton number there. Okay, so let's find the element with 12 electrons. So when I do 23 minus 11 there, okay, what am I going to get? I'm going to get 12, okay, 23 minus 11 So this would be 2, and then this would be 1. Okay, so this element W here, that's 12 neutrons. Okay, so you pick A there as your answer. If you subtract any of these, none of them will get, is going to give you a 12 there. Okay, so the best answer here is A, which is W. Okay, and then question 12, they're saying which element is a noble gas. Okay, so remember by definition, okay, by definition, a noble gas, okay, it is a stable element. Okay, it is a stable element, meaning that its octet rule, okay, is fulfilled or is what satisfied. Okay, so among these electronic structures that we can see here, which one has a full electron structure? Okay, this one here has 281, so meaning it has to lose this one in order to attain stability. This one has 3, so it has to lose this 3 to attain stability. This one has 27, so meaning it has to gain 1 to attain stability. But this one has 2,8. So 2,8, it means its octet rule is what? Satisfied. So this guy here is a noble gas because it has an electronic configuration that is what? Satisfied. So on 12, we're going to say this one, which is on what? Z. So Z there, where's the Z now? So this D here is the one which is a what? A noble gas from that table. Okay. And then question 13, they're saying which two elements are in the same period of the periodic table. Okay, and then they're asking you to also what? State the period. Okay, so from that table, okay, from that table, how can we know that certain elements are in the what? Same period. Okay, so by definition, if two elements are in the same period, okay, it means that they have the same number of what? Electron shells. Okay, they have the same number of what we call as electron shells. Okay, so from here we can see that Y and Z, okay, okay, so we can see that Y and Z, these ones here, are in the same period. Why? Because they both have 2 electron shells. Okay, so this is shell 1, this is shell 2. So they have 2. Even W and X, they also have the same number of shells, so meaning they are in the same period. Okay, so the number of shells that an atom has, it will tell you the period where it is. Okay, so if these have 3 electron shells, it means they are in period 3. These ones here have 2 electron shells, it means they are in period what? 2. Okay, so we have concluded that W and X are in period 3, and they have the same number of electron shells. Okay, so they're in the same period. Even Y and Z, they're also in the same period. Okay, because they have the same number of electron shells. So now, when you come here, okay, which of these answers, okay, is aligned to what we've just discussed there? Okay, so we said Y, we said X and W, Y and Z. So Y and Z, we see this Y and Z, okay, they are in the same period, okay, and it's period 2. So we can pick these guys. And then here B, we have X and W, which are in period 3. So we can also pick these guys here, okay? So you can pick one of the 2 answers there. I don't know why they put 2 answers there, okay? So X and W, they have the same number of electron shells, which is 3. So we'll place them in period 3. And then even Z and Y, they have the same number of electron shells, which is 2. So we'll place them in what? Period 2. Okay, so you can pick this one here, or you can pick that one here. Okay, so you can pick either here. I don't know why they put two answers there. Then let's go to number 14. They're saying which elements form ions with the same electronic structure as neon. Okay, state the periods in which these elements are in. Okay, so which one form the same electronic structure as neon? Okay, so meaning that when those elements are ionized, okay, so when you go to this table here, which of these elements will have a similar structure to this 2,8 when they gain or when they lose electrons, okay? So we see that this Y here is only lacking one electron. So it will gain one electron and then it will have 2,8 when it becomes an ion, okay? So it will gain an electron. So it will become what? Y minus like that, okay? Because it has gained an electron. And then this one here, okay, this one here loses 3 of these electrons. Okay, loses 3 of these electrons to attain this stability. So it will become X and then 3 plus when it becomes an ion. And then this one here loses 1, so it will just be W plus like this. Okay, so on that list of answers that I've given us, we are going to check if either of these guys are there. Okay, so let's go there. So on the answers now, we have which elements form the same as neon. So neon is 2,8. Okay, so from that structure, we saw that all of them, they form, right? Okay, but according to these answers here, which one is the best? Okay, according to those answers, which one is the best? Okay. Okay, let me just go back to this table. Okay, so we saw that this one here, when it becomes an ion, it will form the same structure as neon, okay, and it will be in period 3 because it originally has 3 energy levels. Even this guy here, the X, okay, even it will be in period 3, and then it will have the neon structure, okay, and then for this Y here, it will be in period 2, and then it will have the neon structure. So we are looking for a W in period 3, or X in period 3, and the Y in period 2. So let's go here. Okay, so X and W in period 3, we found it, where is it? X and W in period 3, we found it here. So is there anywhere you can see a Y in period 2? Okay, there is none. Okay, so here they are saying W, X, and Y, and then they're saying these first 2 are in period 2, and then the Y is in period 3. So this is false. Okay, we know that Y is in period 2. So if here it was period 3 and then period 2, there would have accepted the answer. Okay, but we see that there's nothing that is matching the Y, but for the X and the W is there. So we pick B as our best answer there. All right, and then the last question on that table, they're saying, oh, that was the last question, in fact. So now we go to question number 15. Oh, no, we are still on that table. So question number 15, they're saying, on the basis of quantum mechanics, provide the electron configuration, okay, electron configuration structure for element Y. Okay, so let's go to this element Y. Okay, let's go to element Y. Okay, so we are providing the electron structure for element Y. So if we check element Y here, this is element Y here. Okay, so what would be the electron structure? So remember, it has 2,7, right? Okay, so 2,7, we can distribute it into two orbitals. Okay, so the first orbital will be the 1s. So in the 1s orbital, you're going to have these first two electrons. Okay, and then you're going to go to the second energy level. You always start with the s. So the 2s will also have 2, and then you have the 2p. Okay, so now how many electrons are remaining? We have removed these 2 and a 2 from this 7. So how many electrons are remaining? To be 5 there. Okay, to be 5 there. So this here is the electronic what? Structure. Okay. Okay, based on the quantum mechanics, yeah, it should be somewhere here. So we said what? 1 S2, 2 S2, 2 P5. Okay, so 1 S2, 2 S2, 2 P5. Okay, so with p orbital, so there are specifications here. With p orbital having, okay, with p orbital having, so the correct answer here will be these electrons here, these 5 electrons in the p orbital will be filled in, okay, in this way. So we know that in the p orbital, we have 3 suborbitals, right? Okay, so remember in this 5, in this p orbital, we have 5 electrons. So those 5 electrons, you first put 1, you put another one there, and then you put another one there, and then you come back. So you put 1 here, then you put 1 there, and then they are done. Okay, we have finished the 5. So pay attention to what these last parts are saying. So with p orbital having, in the first p we have 2, in the second we have 2, and then in the third one we have 1, which is exactly what is I'm seeing here. Okay, so the best answer here is A. Okay, if you choose B or any other one here, it will be false, because on this B here, they are saying the second one here should have 1 electron, but we see that we have 2 there. Okay, when you go to C, they are saying the first one should have 1 electron here, but we see we have 2 here. Okay, and then here it says 2, 2 everywhere, but we see that in the third one we have only 1. Okay, so the best answer there was A. Okay, the best answer there was A. Right, so that's the number 15. And then number 16 now, they're saying when an electron is described by quantum numbers, n is equals to 1, okay? L is equals to 0, and then ML is equals to 0, and then MS is equals to plus half, okay? In which energy level and orbital can the electron be expected to be in? Okay, so remember those definitions for the quantum numbers. I said the principal quantum number is defined by n. Okay, so we can put any numbers here like 1, 2, 3, 4. So in this case, we've been given that the principal quantum number is 1. And then remember how we defined L. We said from 1, 2, up to what? N minus 1. So here, since the n is 1, it means the L will just be what? 0. No wonder it's 0 here. And then how did we define this ML there? Okay, the spin quantum number. We said it is between minus L, okay, to positive L, including 0. Okay, so we see that minus L will just be 0, positive L will just be 0, and then we have 0. No wonder it's 0 there. Okay, and then so we have ML is equals to 0, and then we have MS there being equals to what? Positive 1 over 2. So in which energy level can we expect an electron that is in this that has these quantum numbers to be? Okay, so the first answer is very simple. Just look at the energy level there is 1. So we can discard this, and we can also discard this. So we are remaining with 1 and 2. Okay, or A and B. So the energy level is 1, yes. Okay. Now we look at the orbital. Will the orbital be S or will the orbital be P? Okay, will the orbital be S or the orbital will be P? Okay, so here, since we only have one energy level, okay, we only have one energy level. As long as you only have one energy level, or your principal quantum number is 1, okay, the orbital that you'll be describing is always S, okay, because in the first energy level, we don't have p orbitals, okay, so the best answer here is just this A here. All right, and then let's look at the other question there, which is question number 17. They're saying when orbitals S, P, D, and F are considered, which one of these is of highest energy? Okay, I already explained this. I said S is the lowest, then you go to P, you go to D, you go to F, you go to G, just like that. Okay, so here we have S, P, D. So the one with the highest energy will be the F. Okay, S with energy will be the F. All right, and then we look at the last question in this quiz. Okay, the last question is question 18. They're saying, how were carbon compounds described in olden days? Okay, how were carbon compounds described in olden days? Okay, so before these carbon compounds were called organic compounds. What were they called? Okay, so traditionally, they were thought to come from living things. Okay, so in the past, they would describe these organic compounds or carbon compounds. Okay, since they came from living things, they would describe them as compounds of animal and vegetable matter, because you know that the vegetable has life, even the animal has what? Life. Okay, so they were described as compounds of animal and vegetable matter. Okay, so here the correct answer is what? D there. All right, so we are done with this revision of the quiz. I don't know if there are any questions from you guys. You are free to ask me. Okay, there are no questions. Okay, so if there are no questions, I'll end here. I'll share the video if you want to watch it at a later time. All right, have a blessed day.
I have a question concerning the timetable.
The what?
I'm saying I have a question, not on this. We are done.